Hopefully I'll see that. Sometimes it doesn't come up. Anyway, so this time, list the EM spectrum in order. So red Martians invade Venus using X-ray guns. That's the way I remember radio waves. M for microwaves, I for infrared, V for visible light, U for ultraviolet, X for X-ray, and G for gamma ray. Your wavelengths, radio waves have massive wavelengths. I mean, like, sometimes they're kilometers. Okay, we're talking massive, massive wavelengths. Hiya, sir. Whereas your gamma rays, that's all right, I can pause in a minute, are very, very small. Very small.
I just feel...
Oh, sorry. Yeah, Mr. Woolley popped in, so I'm going to continue with this now. So I think we were just on about these waves being really big at the radio wave end and then tiny at the gamma. I mean, we're talking nanometers, as we just saw in that other question. And then frequency is the amount of times, and I think there's a definition up here, is the number of waves that pass a particular point each second. Now, that is not the speed of the wave. It just means that if you've got shorter wavelengths, you're going to get more waves passing each second. Oh, hang on. Interrupted again by sixth form. Thank you. Ta-da. Ta-da. All right. Oh, my God. And again, so 3 times. So we were talking about, how many waves pass a particular minute each. Oh, my God. Here's Woolley again. Hang on. Sorry, guys. I have no idea what this bit is going to be like. Anyway. The lower frequency, so if these wavelengths are massive, not many are going to pass a particular point each second. And if the wavelengths are small, then loads of them are going to pass a particular point each second. The speed of these waves, though, are all the same, whether it's a radio wave or a gamma ray. All right, they're exactly the same speed. The speed of light, 8 times 10 to the power 8. Okay, all these are the speed of light. That's why you can watch EastEnders the same time as someone else is watching EastEnders, because it's just a radio wave passing that information. Microwaves with mobile phones, infrared, examples of cooking, things like that, visible light, photography we need to see. Ultraviolet, sunbeds, and checking forged banknotes. X-rays for medical purposes and for security scanners in airports. And then your gamma rays for sterilising medical equipment and cancer treatments, things like that. So, light travels at 3 times 10 to the power 8 meters per second. Sound is slower at 343 meters per second. So you see the lightning before you hear it was the answer to this question. I know I'm kind of rushing now because it's on 14 minutes already. Explain why thunder and lightning are delayed yet actually occur at the same time. So light is much faster than sound there. Let's go to this one by here. Now, why do some waves cause ionization but others do not? Well, it depends really on the frequency. So waves like gamma rays and X-rays have really high frequencies. They make them very dangerous to human tissue. Which region of electromagnetic spectrum has the longest wavelengths? Well, it's radio waves, we just talked about that. And which region of the EM spectrum has the highest frequencies? It's gamma rays have the highest frequencies. I'm going to leave the top boxes to last. No, I'm not. I'm going to go for a wavelength here. Draw a wave diagram and label through trough, crest, amplitude, and wavelength. Now, I messed up my wavelength a little bit here. Basically, a wavelength is one complete cycle of a wave. So you can see it going up, it comes back down. That's half a wavelength right there. And then it goes down and up, and that's a full wavelength. Ready to go again. Up the mountain, down the mountain, yeah? Often you will see it from one peak to the other peak. And that's why I've tried to do it there. And it looks like I've labeled it amplitude, but the amplitude actually is from this line here up to the peak of your wave, okay? So from the normal up to the peak. Then obviously that's your displacement, how far it moves up and down. And then usually time, sometimes distance on the bottom. But that is one wave there. Or you can say from there to there is one complete wave. So it comes down and then back, and then you're going to come down again. Your trough is on the bottom, amplitude is in the middle. That's all that wants. If a wave is traveling 330 meters per second and vibrating at 440 hertz, what's the wavelength? Or the length of the wave? Well, now you would use this one we just looked at down here. You would use that wave equation. So I've got the speed of the wave, or the velocity we say in this case. Velocity is the same as speed. Velocity is just a vector. where speed is a scalar. We learn all about that in year 11. So my speed was 330, which is the same as velocity. My frequency was 440 hertz. I haven't got to do any conversions. What's my wavelength? Well, I cover up y, and it's v over f, which is 330 over 440, sorry, which gives me a length of 0.68 meters. What does the term frequency means? It's the number of waves that pass a particular point or each point each second. And if 10 waves pass a particular point in 5 seconds, what's the frequency? Just a little bit of numeracy. These questions often come up. Well, if 10 waves pass in 5 seconds, then how many waves passed each second? Well, it's going to be 5 into 10, isn't it? And that's going to be 2 hertz. And you can check that then. So 5 times 2 is going to be 10. So that's each second. 5 times 2 for 5 seconds is going to give you 10 waves. We've done that one. We've done that one. Oh, I've only got one left, I think. Oh, that's pretty good. Pretty good. And then all of it, for some reason, they just bang this in, which is all about satellites. It's really weird. It's tagged on the end. I'm not sure if it'll. Sometimes it comes up, sometimes it doesn't. But you know, we'll do some. We'll do a light touch on this. How did geostationary? Well, geostationary just means sticks with the orbit of the Earth. Geostationary. So if the Earth is orbiting, then that satellite stays above one particular point. So if I've got a satellite above my house, as the Earth turns, so does the satellite is going round, and it stays directly above my house. So that's what geostationary means. Pretty much, just it's going to stay above the Earth at that particular point. Satellites orbit have a higher. And they generally orbit on the equator. The equator is the center of the. If you look at a map, it's pretty much that region in the middle where they get all the tropics. So we are north of the equator, and then countries like Australia are south of the equator. So satellite orbit the Earth. How can they be used to send a message to one part or another? So satellites orbit high over. Okay, they use microwaves. So they're going to use microwaves as a transmission signal. So this frequency is high enough to pass through the atmosphere, and they communicate via other satellites and stations on the ground. And I've done a quick little diagram there. Like I said, it's just one. This topic is just sort of tagged on the end. It's difficult to know exactly what they're going to throw at you because they've only had one question, and it was a question like this, where you'd have to say that A would have to correspond to the satellite, and then they would send that message back down to B. So it's impossible for A to get the message to B. Sometimes you'll have other satellites and they'll communicate with each other all around. But these are called ground stations. That's your satellite. I mean, that's pretty much it for that topic, I think. We'll do some practice papers. I think I've covered everything. I'm just trying to look now. Yeah, I have. And that is pretty much that in 19 and a half minutes.